Okay, we have the integral of dx over x squared minus 2x plus 145. So it looks like we have a quadratic in the denominator. So we could either try to factor that or we could try to complete the square. Doesn't look like it's factorable. So let's see what completing the square will get us. There's a long way and a short way to complete the square. I'm going to show you the short way using the vertex. So recall from college algebra that your vertex of a quadratic function is negative b over 2a and f of negative b over 2a. And that's of ax squared plus bx plus c equals 0. Okay, so that's the quick way of finding your vertex when you get it in this form, which this is in this form, standard form. To get it into vertex form, which will be the same result as completing the square, you can use this to write in the vertex, which will be x minus, that's where we plug in our negative b over 2a squared, and then plus f of negative b over 2a. Okay, this will complete the square without having to go through the long process of completing the square. Okay, so given that, we have x squared minus 2x plus 145. We can say a is equal to 1 and b is equal to negative 2. Okay, so that means that negative b over 2a is equal to negative 2 over 2 times 1. Negatives cancel, 2's cancel, that's equal to 1. Okay, f of negative b over 2a, which is the same thing as f of 1, is equal to, well, we plug that into this function, we get 1 squared minus 2 times 1 plus 145. Okay, 1 minus 2 is negative 1, so that gives us f of 1 is equal to 144. So our vertex is 1 comma 144. Now, using our vertex, we'll plug in the 1 right here, and we'll plug in the 144 in place of this. Okay, so I'm going to rewrite this integral over here as dx over x minus, what's negative b over 2a? Well, it's 1. So x minus 1 squared plus f of negative b over 2a. Well, f of negative b over 2a was 144 plus 144. Okay, so that's the quick way of completing the square. Okay, now that we've done that, let's do a U-substitution, because this looks like we may be able to use the formula. Let me write this in a different color. It looks like we may be able to use this formula, 1 over x squared plus a squared dx is equal to 1 over a tangent inverse of x over a plus c. Okay, the difference being that we have, instead of x, we have an x minus 1 squared. Okay, the a is fine because our a would be 12, because 12 squared is 144. So in order to get it to look more like this, let's do a substitution. Let's say u is equal to x minus 1. So if u is equal to x minus 1, then du is equal to dx, term by term. The x goes to 1, the negative 1 goes to 0, so it's 1 dx, or just dx. So let's do that substitution now. So we put it in, we exchange the dx for the du. Du over, instead of x minus 1, we're going to write u squared plus 144. Okay, now it looks a lot more like this. The only difference is our variable is a u, but that won't matter for us at all. We could rewrite this as u here and a u here, and that would be fine. Okay, so we have that our a is equal to 12, and you could write, if you want, that x is equal to u, but I'm not going to. So we have this as our answer, 1 over a, so 1 over 12, times tangent inverse of, we're not using x, we're using u, so u over a, which is 12, plus c. Now, that's in terms of u. We need to go back and use our substitution. Let's move that up so you can see. We need to use our substitution that we did, and instead of ending with a variable of u, our problem started with a variable of x. We need to end there as well. So we'll get 1 over 12 tangent inverse of, let's see, u is equal to x minus 1. So instead of u, I'll write x minus 1 over 12 plus c. And that's the answer.